Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 7 in the SSRF module titled Blind SSRF with Shellshock Exploitation. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Go down, select the learning path. Go down, select SSRF. Go down and select Finding and Exploiting Blind SSRF Vulnerabilities. And then select the 7th lab titled Blind SSRF with Shellshock Exploitation. Alright, let's get started. This site uses analytics software which fetches the URL specified in the referrer header when a product page is loaded. To solve the lab, use this functionality to perform a blind SSRF attack against an internal server in the 192.168.0.x range on port 8080. In the blind attack, use a Shellshock payload against the internal server to exfiltrate the name of the OS user. Alright, so the vulnerable parameter over here is the referrer header that is used when a product page is loaded. And the goal of the exercise is to use this functionality in order to perform a blind SSRF attack against one of the internal servers that is available on this range. So they don't give us the server IP address. We'll have to find that out on our own. And then we're going to use the blind SSRF attack in order to conduct a Shellshock exploit against that internal server and exfiltrate the name of the OS user. And that shows remote command execution. So let's paste this over here. That's a pretty big goal. And let's create an analysis section. All right, let's access the lab. This might take some time. In the meantime, what we're going to do is we're going to open up Burp Suite Professional. And one thing I forgot to read in the exercise is the note that says, to prevent the Academy platform from being used to attack third parties, our firewall blocks interactions between the labs and arbitrary external systems. So to solve the lab, you must use Burp Collaborator's default public server, burpcollaborator.net. So you can't use your own C2 server in order to complete this lab. You do have to have a professional version of Burp. So let's click on Next, Start Burp. Click OK and put it over here. And let's go back to the exercise. Alright, so this is the same application that we saw in the previous exercise. And so we already know which parameter is vulnerable. So instead of looking at that for now, what we're going to do is we're going to take this a step further and talk about an extension that could help you with finding blind vulnerabilities. So not just SSRF vulnerabilities. And that extension is called Collaborator Everywhere. And it's amazing. What it does is it sends non-malicious payloads to parameters. So it fuzzes the application and sees if the collaborator server gets pinged. And if it does get pinged, that means that the parameter is vulnerable to some kind of blind vulnerability. So in order to get this working, what we need to do is we go to Target and let's say Cancel. And add our application to scope. So we haven't loaded up our application in Burp yet. So let's do that and click, let's say View Details. And set Intercept to Off. All right, so we're going to right click this and add to scope. Hit Yes. And now every time I visit any page in the application, it should be fuzzing that in the backend. So let's click Home. And then View Details. Look at this one. And here we go. See, it says you've got a collaborator ping back. So let's look at this over here. And it's in the referrer header and the user agent, which is perfect. So if we look over here, the request that was performed was on the product page where it takes in a product ID and the collaborator domain was added in the user agent. So this way you don't have to test it manually yourself. the extension will test it for you on all the pages that you visit when you're mapping the application. All right, this is perfect. So we already know that this is vulnerable to a blind-based SSRF vulnerability. So let's send it to repeater. And we notice over here, it's not just the referrer header that is vulnerable, but it's also the user agent. So in the previous lab, we successfully showed that it's vulnerable to SSRF, but we didn't show impact of the SSRF vulnerability. And so I see this a lot in the bug bounty world, where you show that something is vulnerable to blind-based SSRF vulnerability, but the impact is nothing. And so the vulnerability gets rejected. And that's why it was really nice to see that Portsfigure included this lab to show impact of SSRF vulnerabilities. And the way we're going to do that is by using a blind-based SSRF vulnerability in order to perform a Shellshock exploit in the user agent. So Shellshock is a vulnerability that I believe came out maybe in 2014 if I'm not wrong, and it's a vulnerability that allows you to get remote code execution on the server that is vulnerable. And the reason it allows that is because there's improper validation of user input, which is the root cause of pretty much 90% of the web vulnerabilities. And so we're going to do that by adding a Shellshock payload in the user agent. Now I don't have the payload memorized, and so I'm just going to Google it. Shellshock. If I can spell that correctly. Shellshock user agent. And hopefully we get some good results. Let's click on Cloudflare, go down, and here we go. So this is the payload. If you've never heard of this vulnerability before, you should read up on it before performing this exercise. So this is what was added in the user agent. So let's copy this and put it in here. Paste it. Now I don't want to eject a disk. Instead, I want to do an NS lookup on the name of the OS user for that server and my collaborator domain. So I haven't written it over here. Let's go back, burp, collaborator client, copy to clipboard, put it in here. That's my collaborator domain that will be used for the attack, and we'll put it in here, paste. Okay, that looks good. Now for the referrer header, we're going to need the range of IP addresses that we're looking at, which is 192.168.0.x, and it's running on port 8080. So let's copy that, put it in here, put HTTP, and let's say 1 for now. It's running on port 8080. Perfect. And hit send. So what this is going to do is, if this server exists and is running on port 8080 and is vulnerable to the Shellshock vulnerability, the user agent will be used when this request is being performed, and that exploit which will run, which should ping our burp collaborator domain and add the OS user's name to the ping. So just to confirm that we've got the right path over here, I'm just going to add a user /bin/ns lookup. All right, so let's go to burp collaborator client and click pull now. We don't get anything. It's probably because there is no web server on .1. Now we have to try all the different IP addresses from 1 to 255 in order to see if there is a web server on that IP address, and if there is it vulnerable to Shellshock. So to do that, we're going to send it to intruder. Go to positions, clear all the positions, and just add this position over here. Next, go to payloads, click on numbers. We want it from 1 to 255. And the step count is 1. And what that means, it'll increase by 1 every time. So it'll start off at 1, 2, 3, 4, 5 until it reaches 255. All right, this looks good. So what's going to happen right now, it's going to try all the IP addresses in the 192.168.0 range. And every time it calls on to this URL, this user agent will be sent with the URL. And if the web server is vulnerable to Shellshock, we should get a ping back to our collaborator domain with the name of the OS user. So let's click on Start Attack. and this might take a couple of seconds. So we could click on pull now to see if we got it already. We haven't, so it might have not reached the vulnerable IP address. And here we go. So we got a DNS lookup. It must have been from the higher ones because we didn't get it before. So if you click over here, you could see that the name of the OS user is Peter. And this is how you gain remote code execution on the server. All right, so to complete the exercise, what we're going to do is click on Submit Solution and put the answer to be Peter. Click OK. And it says it's incorrect, which is weird. And I understand what I'm doing wrong. So it's Peter and then some random string over here. So it's everything that is before the dot because that's how we put our exploit. So we added it as a subdomain of our burp collaborator over here. So that's my bad. Let's copy this entire thing and see if it works. Again, submit solution, paste it, hit OK. And here we go. It says, congratulations, you solved the lab. So now you might be wondering, well, Shellshock has been reported since maybe 2014. Why is this web server vulnerable? Well, this is an internal server, so most organizations patch external servers because those are available for anyone on the internet, which is why the web server itself that is vulnerable to SSRF was not vulnerable to Shellshock. However, when it comes to internal services, there's this notion that they're protected because they're behind a network, and so only trusted users that are available in the network would ever communicate with that service. And that's why they usually don't patch internal services unless they really have to. And that's an incorrect way of thinking because as we saw, we had an SSRF vulnerability in an external service, which allowed us to exploit a vulnerability in an internal service and gain remote code execution within the network. And even if we didn't have an SSRF vulnerability, imagine you just phish a user with a normal phishing email, you get access to the network, and then what you do next as an attacker is look for these vulnerabilities in order to pivot within the network. And that's why you should always patch your servers regardless of whether they're external or internal to your network. All right, so we successfully completed the exercise by exploiting the vulnerability using Burp Suite Professional. This completes the last lab in the SSRF module.